Hey guys, so today we are going to be working on our study guide because tomorrow we will be taking our test. So part of your assignments is to complete the study guide on your Cami page, turn it back into me so we can look at it. Then you have math boxes, and finally you have just play some Prodigy just to get some extra practice and have a little bit of fun. So our goal for today is to review the skills taught in Unit 5 to prepare for the assessment. If you are in the live lesson, then you can ask questions of things that you're unsure of. So looking at question number 28, this is a question that's been on the evaluate. This is one that I don't expect you guys to know because it is a skill that you are just learning. But 0% got this right, meaning nobody got this right. So our goal is to increase this one by answering it correctly. So the question says, the shaded part of which figures represents fractions equivalent to, this is 1/3. Hard to see, but it is 1/3. So right away, I know the simple one is to look at the fraction that has 3 pieces and see that one is shaded. So I know this is equal to 1/3. But here's the thing. It says to shade the figures. This means plural. So I'm going to have more than one. Now, this is where it gets tricky. If I have 1/3, one piece, and I'm looking at 3 parts, I'm not going to be able to say that I have a fraction that has one part, but different amounts of pieces is going to be equivalent. So I know it can't be this one because this is 1/4. 1/3 and 1/4 cannot be equal because we're looking at the same amount of the whole. And if I'm talking about one piece, my 4th pieces are going to be smaller than my 3rd pieces. Same thing over here because I'm looking at 1/6, and 1/6 of the whole cannot be the same as 1/3. One piece of my 6 parts is going to be smaller than 1/3. All right, so now a little bit tricky part. This is something that we haven't, I haven't taught you yet, but it's a little bit tricky and I want to show you. So we can do groups of fractions or groups of the whole and make them into fractions. So I'm going to look at this brown one first, and I'm going to think about how I can split this into 3 equal parts. I'm going to look at putting this as one piece. These are 1. And then this is going to be 1 part. So forget about the line that goes through the middle. If I look at this, I have 3 equal groups, okay? This group right here is one of my 3 groups. So that is 1/3. But because it is split in the middle, I'm going to look at how many of this piece right here is shaded to equal 1/3. So this fraction has a total of 6 pieces, and 2 of them is shaded. 2/6 is equivalent to 1/3, the whole part. All right, now looking at number 2, or actually let's look at the yellow one. So the yellow one, again, we want to look at what is shaded and then see if we can make those equal groups. So for the yellow one, this much is shaded. Same equal group, and this one is shaded. Now, forgetting the yellow lines, how many groups do I have? I have 1 red group and 1 green group. They're the same amount. So this is actually going to be 1/2. And I can say that this 1/2 is not equivalent to 1/3, but 1/2 is equivalent to 4/8. Looking at the pieces on the inside, there are 8, 4 of them are shaded. This one does not work. Okay, now let's look at this final pink one. This one's the trickiest one, I think. So one part is going to be 3 of these pink or purple groups. I want to see how many groups of 3 I can create. So I'm going to make another group of 3, and then I'm going to make another group, and that's all of them. So when I look at it, how many groups of 3 do I have? 1, 2, 3. That means that this section is one of my 3 groups, or 1/3. Now I'm going to look at it with the lines. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 in the whole. 3 of them are shaded. 1/3 is equivalent to 3/9. We should have picked these 3 answers. I think part of why we didn't get very many of these correct is because we had to pick more than one answer choice. So if you didn't pick more than one answer choice, then we would have had a problem. All right, now for our questions for the test, we are going to use our fraction circles to show, to complete this table. So on this one, I'm going to need to find that shade. I need to shade that in. So my words say 1/6 and my number says 1/6. I'm going to shade in one of my pieces. Now on this one, I know the words 1/2. So I have to show my picture. 1/2 is shaded. Over here, I'm going to write it as a number, 1/2. The second row, I have 1/3. So in my words, I can write 1/3. As a picture, I can draw this. I like to put my dot in here, and then I'm going to make a Y. So I have 3 parts, and I'm going to shade in one of those 3 parts. Now we're going to pretend this was already shaded in, because this is going to be 1 part out of 4. So that fraction in words is going to be 1/4. And to write it as a fraction, 1/4. You are going to have to fill in a chart like this on the test tomorrow. You're going to fill in this table. Okay. Looking at the next one, this is if we were doing a fraction memory card game. It's kind of like Fraction Top It, where you're turning over cards, but you're doing it as a memory game. You're trying to find matching fractions. So Nikki turned over these 2 cards during a fraction memory. He thinks he found a pair of equivalent fractions. Remember, equivalent means equals. This fraction is 3/4, and this fraction is 1, 2, 3, 4, 5, 6, 8. And we need to know if they are equivalent. So I agree with Nick. That's my first sentence that I'm going to have to answer. Do I agree with him? Yeah. Then I'm going to answer it. So when I look at this, I have 2 circles, and these 2 circles are the same size. Then I'm going to look at what's shaded on the inside. Well, in the inside, I have the same amount shaded. So I know that these are equivalent fractions. In fact, one thing that I could do is if I were to kind of get rid of those lines in the middle of this one, I'm going to see if I could split it into fourths. And when I split it into fourths, I can see here's 1/4, here's 2/4, and 3/4. So they are equivalent. All right, so here's what I said. I agree with Nick. The circles are the same size and the amount shaded is the same. 3/4 equals 6/8, or 3/4 is equivalent to 6/8. Okay. Part B says use your fraction cards to find a different amount of equivalent or a different pair of equivalent fractions. Record your fractions on the lines below. So in the back of your book, we had those fraction cards that we could cut out, and you can use those to see which ones are equivalent. One thing that I could show to be equivalent would be if I were to have 1/2. So this is 1/2. And then I want to show another circle, so the same size circle, but maybe I want to do it into 6. So I could show that 3 of my 6 pieces are equivalent. So 1/2 is equivalent to 3/6. This is not the only pair that you could use. This is just the one that I picked. If you want to show 1/4 equivalent to 2/8, perfectly fine. Equivalent fractions just have to be the same amount. All right, number 3 says complete the table of 3's multiplication facts below. So remember the fact and then the product is the answer. So these are my factors, and then I'm finding the product or the answer. 1 times 3 is 3. Anything times 1 is the other number. 2 times 3, I could do 3 plus 3 or 2, 4, 6. Count by 2's, that is 6. 3 times 3 is 9. And 4 times 3 is 12. Now, what patterns do you notice in the products? The products, remember, are the answers over here. What pattern do you notice? I'm going to use my erase strategy, making sure that I restate. So I notice that the products increase by 3. That's one pattern I notice. I also notice another pattern. They go even, sorry, not even. The pattern goes odd, even, odd, even. So my pattern is odd, even, even, odd, even. So I notice the pattern odd, even, odd, even. And we learned that it goes odd, even because it is 2 odd factors make odd, and then 1 odd, 1 even make even an even number. So every time I multiply, 1 times 3 is odd, odd, even, 3 is an odd, 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 even, odd, 3 is odd always. So you always have this even, odd pattern. All right, I'm gonna have to go back a few slides. Okay, so number 4, use a helper fact to solve this problem below. You guys could pick any helper fact you want to. We learned yesterday the break it apart strategy. So we could break apart some numbers. We could do doubling. We could do a lot of different things. But we're looking for a helper fact. So I want to draw a picture, because multiplication for me is like doing area. And I think I want to do a double, because 4, like the half of 4 is 2, and I definitely can do 2's in my head. So instead of having 4, I'm going to have 2 and 2. This first area is going to be 2 times 9, and that equals 18. The second area will be 2 times 9, and that also equals 18. So the helper fact that I use is 2 times 9 equals 18. When I do 18 plus 18, that equals 36. So 9 times 4 is 36. All right, number 5. Thomas is playing a round of salute. The dealer says 36. His partner has a 6 on his forehead. What number does Thomas have? So remember, when we're thinking about salute, it's finding the missing factor. So his partner has 6, and whatever his number is, when they multiply, it equals 36. That's how salute works. One way that I can do that is if I can count by 6, I could, but counting by 6s is difficult. You might know your multiplication facts, and that's awesome, but I don't, so I'm going to use my fact family to come up with this problem. 36 divided by 6 equals my unknown number. So I'm going to draw 6 equal groups, and I'm going to split 36. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. When I split those out equally, I can see that each group has 6. So 36 divided by 6 equals 6. That must mean 6 times 6 equals 36. So what number does Thomas have on him? It is 6. Write a multiplication number sentence and a division number sentence for this problem. I mean, when I was trying to solve this, I already came up with them. So I've got 6 times 6 equals 36. And 36 divided by 6 equals 6. How do your number sentences show the same salute round? So we know that multiplication and division work together to create fact families. Okay, well, let's look at the next one. It says divide the circle into 8 equal size parts, shade and label one part of a fraction. So first, when I'm going to do this, 8 is even, so I'm going to go down the middle. I'm also going to go across the middle, and then I'm going to draw my X for 8. So now I have 8 equal pieces. Then it says shade, so there will be 3 points for this one. Divide, shade, and label. So there's shading one part with a fraction. My fraction is going to be 1/8. All of these are 1/8 as well. Could easily label all of these, but I wanted to shade one of them. All right. Number 7, Madison is trying to solve 9 times 6. She sketches a rectangle to help her think about how to break apart the numbers so that the facts is easy to solve. Here's her sketch. So we know that this side is going to be 6, and this is going to be 9. I want to break them apart into numbers that I can use. 6 is even, so I could do doubling, but I would have 3, which is going to be a little bit harder for me. This one is a fun one because it seems so simple when we can break it apart this way. I'm going to break apart the 6. I'm going to break it apart into 1 and 5. 1 plus 5 is 6, so I could break it apart into 1 piece and 5 pieces. So To solve that, I'm going to do 1 times 9 equals 9. And then I'm going to do 5 times 9, and that equals 45 because I can count by fives. Then I want to put them together. 45 plus 9, well, that equals 54. Use numbers or words to explain how Madison can use her sketch to solve 9 times 6. So I drew my picture, but I also want to write my words. So Madison can split 6 into 1 and 5. Then she can find the area of 1 times 9 and 5 times 9, and finally add them together. So splitting it can help us to solve the problem by using the area. All right, number 8. Use square helper facts to, what square helper fact could you use to solve 8 times 9? For this one, I think that we don't all know our squares yet, so I would be okay with you solving any way that you want to. If you want to split the 8 into equal groups and double it, then you could do that. So as long as you're able to explain it to me. So I'm going to use this 4 times 9 as my helper fact, and that's 36. So what helper fact did I use? 4 times 9 equals 36. How would knowing this answer help you to solve 8 times 9? Well, you could say I would double 36 because I found the product of half of 4. So that is one way to do it. You could also do add a group or subtract a group. So I might do 8 times 9. This is close to 10, so I'm going to change this to 8 times 10, and that equals 80. But I don't have 10 groups of 8, I have 9 groups of 8. So then I would have to subtract 8, and that leaves me with 72. I guess I should finish it out and say 36 plus 36 equals 72. So either way that you solve it, I'm okay with you solving it anyway, just as long as you're able to explain it to me. And that is the end of the study guide. If you, I hope if you're watching this and not doing this with our lesson that you are pausing to write in your study guide online and then turning that into me. Then you have your math boxes, and finally you have Prodigy. And that's it.